So today we're going to talk about some methods for figuring out drug dosaging, calculating total volume given. The first thing we're going to talk about is the tried and true method, which is desired dose divided by dose on hand times volume on hand. That's always going to give you the correct volume that you need to give. The next thing we're going to talk about is figuring out drip rates. And I got a formula here. It's total volume times the drop set divided by the times a minute that we need to give that, and that's going to give us how many drops a minute that we need to give. The next thing is dopamine. If you guys remember from dopamine, there's a quick method to figure out our beta dose, and for our alpha dose, we simply times that by 2. And the next thing I'm going to talk about is a quick mental math thing that we can do in the field to figure out Versed, fentanyl, and ketamine, and then lastly, etomidate. But before we go over those different methods, I'm going to review converting pounds to kilograms. So we're going to talk about converting pounds to kilograms, and what you can do is take their weight in pounds and divide it by 2.2, and that's going to give you the exact weight in kilograms. Or you can simply take their weight, divide it by 2, and minus 10%. So we're going to do both methods here. So let's say they are 180 pounds. What we're going to do is divide that by 2.2, and 180 divided by 2.2 is going to give us 81 kilograms. And that's the weight that we're going to use to calculate our drug dosages. Or, this is the method I like to use in the field, 180 divided by 2 equals 90. And then I subtract 10% of 90, which is simply going to be 9. So 10%, 90 minus 9 is going to give us 81. Now, this is going to be right in the ballpark. This is going to be exact. Now, if you look at these, they look exactly the same, but this is really 81.81, so they're probably closer to 82 kilograms. And as we go through the different spectrum of weights, this is going to be either a little bit closer, a little bit further away, but it's always going to give us right in the ballpark. Alright, so the next thing we're going to talk about is how to figure out how much volume of the drug we're actually going to give, because we figure out how many kilograms they are, we know how much of the drug we need to give, our desired dose, but now we need to figure out our desired volume. Because let's be honest, if I know I need to give, 45 micrograms or 0.23 milligrams, like what good does that do to me if I don't know what that actually means for me to draw up in a syringe? So we're going to go back to our previous example of an 81 pound or 81 kilogram patient, and we're going to talk about fentanyl. So our desired dose for fentanyl is 1 microgram per kilogram. So if they're 81 kilograms, that's going to be 81 micrograms is our desired dose here. So our dose on hand, as we all know, is 100 micrograms in a vial of fentanyl. So that's going to be 100 micrograms, and it comes in 2 mLs. So what we're going to do is we're going to divide 81 by 100, and that's going to give us 0.81. We're just going to times that by 2 mLs, and that's going to be 1.62 mLs is what we draw up for fentanyl. Now let's say we got a different drug. Let's say pediatric amiodarone, so we'll come up here. So amiodarone, we know, comes in 50 milligrams per 3 mLs. And our pediatric dose of amiodarone is 5 milligrams a kilogram. So let's say we have a 30-pound patient. So if we take 30 divided by 2, it's 15 minus 10%, which is going to be 1.5. That is going to give us 13.5 kilograms. I'm just going to round this up to 14, and I'm going to times that by 5, which is going to give me 70, I believe. Let me check with my So 14 times 5, 70. Perfect. Alright, so we have 70 milligrams is our desired dose for amiodarone. Because if you remember, I rounded this up to 14. So 14, and it's 5 milligrams a kilogram. So 14 times 5, 70 milligrams. So what I'm going to take is my desired dose, 70 milligrams, and I got 50 milligrams in 3 mLs. So what I'm going to do is I'm going to take 70 by 50, and this I can't do in my head. So that's going to be 1.4. 70 divided by 50 is 1.4 times 3. So I'm going to give a total of 4.2 mLs. So I'm going to need 2 vials, and I'm going to draw up 4.2 mLs, and that is my pediatric dose. Typically for amiodarone, we give it over 10 minutes, but just after reviewing the protocol here for pediatric amiodarone, it is over 20 minutes. So we'll figure that out for pediatric amiodarone. So we have our total volume here, which is, in this case, 3 mLs for the amiodarone plus 50 mLs for our piggyback bag. So the total volume is going to be 53. Now we're going to multiply that by our drop set. So as you all know, we have different drop sets. We can have a drop set with 10 drops a minute, 15 drops a minute, 20 drops a minute, or if we go into our micro drip, to 60 drops a minute. So for easy math here, we're going to say we have a 10 drop set. So we're going to multiply 53 by 10, and that's going to give us 530. So now we need to divide 530. So if you think about it, 10 drop set, that's 10 drops of milliliter. And if we have a total of 53 milliliters, this number equates to 530 drops to give the whole thing. So 530 drops is going to give that total 53 milliliter piggyback bag of amiodarone that we have. So what we want to do is figure out how many drops a minute we need to give in order to give this 530 drops over, in this case, 20 minutes. So what we do, we take our time, which is 20 minutes, and we're going to divide 530 by 20. 26.5 or 26. So 26 drops, or you can just round it up, 30 drops a minute, or half a drop a second, or 1 drop every 2 seconds. And that is how you would give the amiodarone, pediatric amiodarone. So now let's just do this again, just so you guys are comfortable with it. But we're going to do it over 10 minutes for our adult dose of amiodarone. So for adult amiodarone, we have 3 mLs plus our 50 drop bag, so that's going to be 53 total, 53 milliliters, and we're using the 10 drop tubing, so we got 530 drops total over 10 minutes. So we divide that by 10, and that's going to give us 53 drops a minute. I would round this up to 60 drops a minute, which is going to equal 1 drop a second. We're going to talk about drip rate for dopamine. Now, this is kind of a special rule that we have. So for dopamine, we're either giving it in a beta dose or an alpha dose. So the beta dose, that's going to work on the beta 1 receptors. So beta 1 receptors typically increase heart rate and the contractility, so it's going to increase the strength of contractions. So when we're giving the beta dose, think congestive heart failure or post-cardiac arrest, and they are hypotensive, we want to start with the beta dose. So for beta dose, think heart-related, or for giving the alpha dose, that's more of like their blood pressure's tanking because of things like neurogenic shock, anaphylaxis, septic shock. In alpha, the alpha 1 receptors cause vasoconstriction, so that's when we're giving the alpha dose. Now, always with the beta dose, like if it's CHF, we're going to start at the beta dose and we're going to slowly titrate it up to effect. We may get into vasoconstriction, which is going to help increase their blood pressure as well. But for anaphylaxis, neurogenic shock, anything like that, if it's not heart related, you're going to start at the alpha dose. So to figure it out, if you guys are probably looking up here, approximately 10% in weight in pounds minus 2. That's kind of a weird way to say it, but that's essentially what it is. So as you all probably remember, you take their weight in pounds, you chop off the last number, so approximately 10%. 10% of 180 is 18, so that's what that means. So 18, then you minus 2, 16, and that is 16 drops a minute is our beta dose. So we got a congestive heart failure patient and we decide we need to give dopamine. We are going to do medical emergency. We're going to do 16 drops a minute. Now keep in mind, I didn't mention this, with our 60 drop tubing, our micro drip tubing. So 16 drops a minute with our 60 drop tubing. That is our beta dose for dopamine. Now let's say 16 is not really working, so we're just going to slowly titrate this up to effect. Now let's say instead of heart failure, it was neurogenic shock. We need to give our alpha dose of dopamine. We're just going to simply do the same method. We got 16. We're just going to multiply it by 2. So that's 32 drops a minute, or 1 drop every 2 seconds. That is our alpha dose. So if we're starting with our beta dose and we're slowly titrating it up, as we get closer to 32, we're going to start getting more into our alpha dose. So if it is the case of a heart failure patient, we don't necessarily want to cause vasoconstriction because that's going to increase the afterload on the heart, which might be worse for the patient. So bear in mind when you are therapeutically giving the beta dose and we need to titrate it up, be wary of getting too close to the alpha dose here. So now we're going to talk about some quick field math to help us figure out the drugs that we give, fentanyl, Versed, and ketamine. Apparently I can't spell. So ketamine. So I don't know about you guys, but I hate being in the field and I need to figure out a drug dose and the volume I need to give. The patient tells me their weight and then I'm like, what am I going to give? I hate that feeling. I like to take the patient's weight and then just after a quick few seconds of thinking, be like, okay, this is what I'm going to draw up. So for fentanyl, our dose is 1 microgram per kilogram. Versed 5 to 1, so that's the little vial. We're going to be giving this IN or IM. The dose is 0.1 to 0.2 milligrams a kilogram. This method, I always do the 0.1 because it's easier math, and I can always just re-give my dose if the 0.1 milligram per kilogram didn't work, and then I'll be at the 0.2. So I always figure it out for the 0.1. And then ketamine for pain is 1 milligram per kilogram. Now I know we mainly give ketamine for DAI protocol, but we can also give it for pain. And if you figure out at 1 milligram per kilogram, you can just multiply that by 2, and that's what you're going to get for the DAI. So the method that I'm going to discuss here is going to give you your dose for all 3 of these drugs. So let's say, I don't know why I like 180 pounds, but I do. Maybe that's because what I want to weigh one day. So we take 180-pound patient, and they're in a lot of pain. They're very anxious, and I'm worried about a respiratory compromise, and I may need to DAI them. So I'm like, shit, I got 3 drugs I need to figure out. What do I do? So I'm simply going to take 180 pounds, and I'm going to subtract 10%. So, or if we just talked about dopamine, 10%, 18. So I'm going to take 180 minus 18, and I got 162. So I need to give them fentanyl, I need to give them Versed, and I need to give them ketamine because I might DAI them. Who knows? So I'm going to take 162, and I'm going to move the decimal over 2. So 1.62. All right. So I don't have an IV established. They're fighting me. So I need to sedate them. All right. So I'm going to take 1.62 mLs of Versed, 5-to-1, and I'm going to give that IN. So I drop 1.62 mLs, I give it IN, and that is my correct dose for Versed. Now my patient is nice and sedated. I can start an IV. They're looking at me. They're like, oh, I'm still in a lot of pain, but they're calm. So I'm like, okay, I'm going to give you some fentanyl to help with your pain. So I'm simply going to drop 1.62 mLs of fentanyl. And that is going to give me 81 micrograms of fentanyl. So if you remember, we didn't talk about it, but 180 divided by 2 is 90, minus 10%, or 9, is 81 milligrams, or kilograms. So I need to give them 81 micrograms of fentanyl. That's going to be 1.62 mLs. I need to give them 8.1 milligrams of Versed. That's going to be 1.62 mLs of Versed, 5-to-1. So that is how that works. Now, ketamine. Same thing with ketamine. For pain, it would be 1.62 mLs. But now let's say they're in respiratory compromise. I need to give 2 milligrams a kilogram. So I just simply take 1.62, multiply that by 2, and that is going to give me 3.24, I think. So for that, I'll just use a calculator. 1.62 times 2, 3.24 mLs of ketamine for DAI. A new drug that's relatively new to our protocol is etomidate. We're going to give this for DAI. As you guys all know, the dose is 0.5 milligrams per kilogram. We carry it, it's 40 milligrams and 20 mL, so our max dose is 40 milligrams and 20 mLs. Another way to say 40 and 20 is 2 and 1. So we got 40 milligrams, 20 mLs as our max dose, so we all know since it's 0.5 milligrams per kilogram, if we had an 80 kilogram patient, they're going to receive the full dose, so 80 and above is automatically going to receive 20 mLs of that etomidate. So the way I like to do it is I just take their weight in kilograms, I divide it by 2, which is 40, and I divide it by 2, which is 20 mLs. So I know any patient that is greater than 80 kilograms, so 80 times 2.2. So if they're an average adult male, that's 176 pounds. or heavier, I'm automatically just giving this whole dose. So, but let's say we have a 130 pound, patient again. 130 pounds divided by 2.2 is going to be 58.5 or 59. So 130 divided by 2.2, just verify that. Yep, so 59. So we got 59 kilograms or 60 kilograms, whatever. You're going to divide that by 2. So that's 30 divided by 2. That is 15 mLs of etomidate given. So let's just verify that this method works. So we're going to give 60. We're going to give 30 milligrams, so there's 60 kilograms, 0.5, we're giving 30 milligrams of etomidate. We got 40 milligrams on board, and we got 20 mLs total volume. So 30, 40, that is 75%, 0.75, 30 divided by 40 times 20. I didn't do this ahead of time, so let's make sure it's correct. 15.75 times 20 equals 15 mLs. Alright, we're going to talk about the dial flow tubing real quick. The dial flow tubing that we carry delivers a specified amount of milliliters per hour. If you can look closely at the picture here, you can see that the range is between 10 milliliters an hour to 250 milliliters an hour. So unfortunately, this is not going to be adequate for most of the drugs that we give via drip, such as amiodarone or possibly magnesium sulfate if we carry it in the bag, which is 2 grams per 40 mLs. And it's definitely not going to work for dopamine because we need to use the micro drip tubing. So reviewing the protocol and thinking off the top of my head, really the only drug or medication that this is applicable for us and actually pretty helpful is for burns. If you can look at the protocol below, in the initial hour or in the initial fluid administration, we're going to give a certain amount of milliliters per hour. So less than 5 years, it's 125 milliliters an hour. Between 6 and 13, it's 250 milliliters an hour, which if you look here is the max that the dial flow can go. And then for greater than 14 is 500 milliliters an hour. So if we do have an adult trauma, we're going to need to establish 2 IVs and hook up these dial flows and give them 500 mLs an hour. Or you can simply do our calculation that we discussed before and make your drip rate approximately 500 drops an hour that way. But we have this dial flow as a tool, so if we can utilize it and make our lives easier, we should do so.